Fine. This is a private video. I'm just recording it for your own sake. Because usually, at least when I was learning, it was better to, I had my mentor just like record and I would go back to it. So you definitely know the basic data types, right?
Yes.
With double, in which case we can say, 10.5. This would not be compatible had I put it here, right? It would give me an error. It would say I'd have to store it in an integer data type. Double are just decimals. So int, double. The other major one you'll see is string. And let's say my name, right? So you'll see int, double, string. These are more or less the basic ones. There are some other ones like long, and so on and so forth, but these are really the basic ones. And then of course you know that you can perform arithmetic with them, right? So you can say system.out.println. Now I can say x plus let me introduce another variable z, right? And I could say x plus z. Now there's one problem here and it's not going to let me run. Why is that?
System. Is it because we didn't? I don't know how to put this. Is this because we didn't use public static void main?
Exactly.
Okay.
The main method. What's your understanding of the main method? Public static void main, an argument of string args. It's where you execute. This is the entry point to the program, right? So if we put it all in there, then it permits us to run code, right?
Right.
And we get 15. So there's that, right? There's that idea. Now, so you can do arithmetic, you can divide as well, and then we'll be able to run this here.
Would we be able to add x to y like in JavaScript, or
add x to y in the sense of like saying 5? Yeah, you can do that. You can do that. So 5 plus y, or not 5 plus y, but x plus y rather, right? You can do that. You can do that in every programming language. The problem is it's going to always take the side of the double. So it's not gonna, it will not, what they call truncate, which is when they drop the decimal. But it will take the side of the double in that case. So they're definitely compatible in that way. This is true for all programming languages. Now, yeah, and then of course you have multiplication like this, right? I usually don't go for that. I can say this. And divide, multiplication, subtract, you can say subtract as well. So there's that. Now, beyond that, there is this idea of concatenation, right? Do you know what concatenation is?
it's when you, I think, like combine two strings or an integer with the string?
Yeah, exactly. So if I had a name here and that name was, let's say, John, and let's say I had, John had a cost. Let's say I computed that cost somewhere, what it costs for whichever object. I can then introduce a print line statement and I can say, hello, and then plus. So this plus is the concatenation trigger, plus the name, plus the name, and then I have to add a space plus the cost. Now, this is a really tiresome way of doing it. JavaScript does not do it. You can do it in JavaScript this way. JavaScript has a different way of doing it, which is more intuitive, but in Java, you're stuck under this constraint. Hello, John. I could just say something your cost is, and then it'll say, your cost is, your cost. Okay, see, I have to add a space there. I could say your cost is 5. And then I could be even a little more fancy. I could say, well, let me just add a, your cost is $5. Now, in this way, you already said you know what the scanner is. So what is the statement for the scanner? How do we introduce the scanner?
So I think we import the scanner,
Yeah, we definitely
right?
import it. What's the statement though? Because you'll find that if you don't import it, it will make you import it and it'll actually do it automatically.
Okay.
Okay.
So I think we create a scanner object, right?
Mm-hmm.
I remember, so I think it starts with scanner,
Uh-huh.
and then I think the name of the scanner.
Yes, we'll call it my scanner.
And is it like new or
New-
equals new?
New scanner, right? And then you're taking the input from the system. So system.in. Okay. Now this is going back to what I had said before, which is if you don't import the scanner, then you can hover over it. This is true for all IDEs. It will make you import it. It will make you import it. Does that see what I'm saying there?
Mhm.
So the format here, right? And this is true for all objects. The format, and I'm going to write this here. This is how you do a multi-line comment. The format here is object name. So the name of the object is the scanner. So you do object name first, then personal object name, so that you get to name the object now, equals new, again, object name. Okay. For the scanner, there's just an additional parentheses within which you put system.in so that the scanner knows where it's supposed to expect input, which is from this console down here, which is called system. So for all objects, this is true. First, the object name. If I had a dog object, I would put dog, and let's say my dog's name is, I'll call it dog1 equals new dog. That's how I get that there. And then the parentheses at the end. This is the basic syntax for declaring and instantiating all objects. There's a very fine difference between declaring and instantiating. Declaring is, I can say string name and leave it at that. Instantiating is saying, okay, well, name is equal to John now. You see what I'm saying?
Okay.
So it's
So is
two parts, yeah.
instantiating is assigning a value?
Exactly.
Okay.
Exactly. See, when you say string name, and this is the more proper set of terms for it, when you say string name, you are, so when you say string name and you leave it at that, this is allocating a space in memory for a value which is of the string data type. Okay. When you say name is equal to John, I'll add the H there just because you don't have it usually.
Yeah.
You are assigning a value to that space in memory. Not an important detail, okay, but still kind of important. So declaring, instantiating, and that's the idea, right? Concatenation is just because you want to make sure you add these extra spaces here. If I just said hello and added the name here, that wouldn't work too well because they would merge together, right? You say hello, John. See how they're merged?
Yeah.
So you actually have to take into account the spaces. Okay, I didn't do that here. I realized they were merged. I added that fucker in, right?
Yeah.
Now, so this is, yeah. Now we can say, now how are you gonna, so what I'm trying to do here is I'm trying to not hard code it. So hard code is a term. Do you know what hard code means? Hard code is a term used for assigning values prematurely and not letting users enter a value, which is what we did here. We assumed every user had the name John, right?
Right.
Now, I don't want that. I don't want that. So I'm going to remove this. I want the scanner to take that name in. So how do I do that?
All right. I think I think we do name equals my scanner dot next line or something like that.
So we do, yes, string name, because remember, I erased all of it, right? So
Right.
the data type, and then the name of the variable, we can call this even username if you want, or we'll just say name. String name equals Now the name of your scanner. So your name of the scanner was my scanner. Dot next line, as you had mentioned. Next is only just going to take one word. Next line takes the whole thing. And now you've introduced the scanner and you're now receiving input. Before, of course, you take that input, you need to ask for it, right? So you need to say, well, what is your name? Right. So the chronology is you introduce the scanner, you ask what the name is, then you store that name in a variable, right? String name. Now you could, of course, first do this the opposite way, where you say, okay, well, string name instead, you just like that, and then you could just say name down here, right? Same idea, same idea. But most commonly, you'll find this pattern happening the most, where they introduce the scanner, they ask the prompt, this is the prompt, and then they store my scanner.nextLine will get the input, and it's storing that in the name variable. Okay. So it says, what is your name? I say, my name is John. It says, hello, John, your cost is $5, right? And every time you want to duplicate this type of pattern, so now let's say I don't want to hard code the cost. I do the same thing for the cost. What is your cost? And then instead of storing it in an int or a string, I'm storing it now in an int, and I'm saying my int cost is not next line, but what do you think it'll be here?
Next integer.
Next integer. Well, not integer, but int.
Oh.
Int. Because remember, we're talking about int here. So cost is giving. Why is this giving me why is this red line here?
Because it's already been. I forgot what the word. It's not instantiated. Has it been instantiated?
It has, because remember, by this point in the program, think of programs from top down. This is what they call the waterfall method, right? Where the what they call the interpreter will read the program from the top sequentially downward. So by this point in the program already knows that by this point, something has already been taken for input.
Right.
And yet again, you're trying to take it again. I mean, it doesn't, for the same variable, it doesn't make sense.
Right.
So it's a duplicate. It's a duplicate. That's out of the way, right? So, and now it says, what is your cost? And then we were able to print these both out. What is your name? Is John. What is your cost? It's $5. Fair? So yeah, so these are things you already know more or less. I'll write this as a note here for the scanner, right? So how do you do that? Scanner declaration is scanner, your scanner name equals new scanner, system.in. That's the thing. And then I'm going to put in the parentheses, import if error shows. Okay, on top of that, I'm saying now, system.out.println, print a line, outprint a line to the system, right? So system.out.println, whatever you want your prompt to be. And then, this is an example, data type, name of data type, or name of data equals new, or equals your scanner name dot next line slash next int, right, slash next double. The next double that they enter will be stored. The next line or the next string that they enter will be stored. The next int that they enter will be stored. Concatenation, I'll just put this here just for an example of concatenation. Fair? Okay. So that's the idea, the basic idea, right? Now, the next step up from this point is conditionals, right? Do you feel like you have a good grasp of conditionals? I could do them real quick.
Like if else and a switch statement, right?
Switch statement, you'll very rarely see a switch statement. I'll tell you this, you'll very rarely see a switch statement. But if else, I would say is more of a priority. So, if we have int x equals 5, I'll say, so the idea, this is the structure. This is the structure. I'm writing the structure here. The structure is if condition logic. Else if condition logic. Else final logic. See what I'm saying?
Mhm.
Now, when I say if condition, I actually mean if condition is true. If condition is true. Because if it's not true, we'll never enter this these brackets. So we'll see an example of that. Int x equals 5. If x is equal to 5, we'll perform logic. Let's set x equal to 6. Right? Else if x is equal to 6, right? X is equal to 10. Else x is equal to 0. Fair? So, and then we'll print out x finally at the end. So ideally, what do you think the output should be?
It should be 6.
It should be 6, right? It should be 6. Right? Because so what it's done is top down, it said, well, is it 5? Yes, it is. X is equal to 6. Now I enter this case, right?
Mhm.
This time x is equal to 6. 10. Now, in this case, if I say 0, if it's not, so how do I get in the last clause? Let me ask you that. How do I get myself in the last clause? Else.
If it's not 5 or 6, right?
Yep. So if I say 4 here, you'll see this happen, I get 0, right? Before we go forward, there is one other thing with basic Java in terms of numbers that those are increment and decrement. If I declare a variable here, and I'll comment this out. If you want to comment things out, well, I'll tell you that later. But int x is equal to 5. Let's say if I say x plus plus, and then I do system.out.print line, and I print out x, it's going to essentially add 1 to x. Okay, so x plus plus is going to add 1 to x, right? So if I do x minus minus, what do you think would happen there?
We'll get 4.
Yeah. See how that works?
Yes. So we
Yeah.
decremented it.
Decrement, right?
Decrement.
Exactly. So that's the idea behind decrement and increment. And of course, I'll say x, I'll say, well, I'll put that down here before this if else topic. I'll say that, decrement / increment x plus plus, or, variable name, whatever you want to call it. Variable name plus plus, this is increment. Variable name minus minus, this is decrement. Okay. Specifically, these are called post decrement, post increment, particularly because this happens after the code executes. That's more of a different type of nuanced topic. You could put this here as well before the variable, the minus minus. You can even put the plus plus before the variable, in which case it will increment or decrement after the code executes. And that's more of a nuanced thing, which we'll talk about later. But back to logic, right? And of course, in terms of data type, now that I'm thinking about it, there's an additional data type. Have you heard of a Boolean?
Yes, that's true or false, right?
Exactly. So when we were covering data types, remember we said a few things. We said They're just four. I'm just writing four different types of examples. String name John, int x equals to 5, double double y is equal to 4.2, and then Boolean. Boolean equals false, or Boolean equals true, right? So actually what happens, and this is actually what happens is when you come into this condition, it's treating this as a Boolean. It's saying, is x equal to 5? And so it is treating x equal to 5. It's going to return a Boolean value, right? It says true, go inside the clause, the brackets, right? So whenever you talk about these things within the parentheses, these are actually Boolean logic is what they call them, Boolean logic. Logic that results to some type of a Boolean value. So there's that. I'll give you sort of a and in terms of Boolean logic, we'll cover operators, right? So int x equal to 5, int y is equal to 10. So if x is greater than 5, so you have greater than, less than in the same way you would imagine. If x is greater than 5, system.out.println, yes, right? So else if x is less than 5, no, right? So you see how that works in the same way you'd expect. And now, what's the problem here?
It's neither greater than or less than 5.
Exactly. So I need an else here. Not greater than or less than, which is what I should get ideally, right? Not greater than or less than. Now, of course, I could have said, y is equal to 10, and I could say, I could change these to now compare x with y, right? Instead, in which case it would do that. And of course, x is less than 5, so it's saying no. But you also don't always need all three, right? You don't always have to stick to if, else, else, or if, else, if, else. You see how that's what we've done 2 or 3 times? If, else,
Right.
You can just you can stick to if, else also, right? You can just say if and then else. That will also work. And then of course it would just run in whichever way it should, right? So it would say, well, it's not greater than or less than because x is in fact not greater than y. 10 is not great. 10 is greater than 5, so it's saying, well, 5 is not greater than 10, so it's saying not greater than or less than. So the two operators here, greater than, less than, those are 2 of them, right? Now another one exists, which is what we call not equals, or an exclamation mark followed by an equal sign. This is to say that x is not equal to 5. So this not equals is what is called a negation operator, in which case it is judging whether or not something is not true. And of course, as we'd expect, it says yes, because x and 5 are not equal, right? So this is the negation operator, fair? And so this is, so greater than, less than, not equal to. Now there is an or operator. Now the or operator is either this can be true or this can be true, whichever one is true, or if one of them between both are true, will execute what's in the block of code. So I could say if x equals y, or y is greater than x, then print yes. So X is not equal to Y. It looks at this, it says X is not equal to Y, but I still have another Boolean condition to check. So it says yes, right? It says yes, because one of them are true. Now, if I had not included this here, I would not be in this first if statement, right? I jumped to the second one. But if I now add it, then things tend to work. Okay. So less than, greater than, not equal to, or. And then the and percent. So and, which means now, in order to enter the block of code, both have to be true unequivocally. So X, first of all, this just doesn't make sense, right?
Right.
But X has to be, let's see this here. So X has to be, or this would make sense. Y has to be greater than X. And Y divided by 2 must be equal to 2. Now we're fine. Both of those are true. Or Y divided by 2, 10 divided by 5. See, now we're fine. Right? Now we're fine. So you see what I'm saying? So both of those have to be true if you want to enter the if statement. Right? Y has to be greater than X, which it is. And Y divided by 5 is equal to 2. Now, this, we're starting to also talk about just like code philosophy to some extent, but it's not good practice to do arithmetic in these conditions. It's not good practice. Okay. What could you think of as an alternative solution to not having to do Y divided by 5 in this condition?
Is this what we would use a Boolean for?
Well, the whole thing is a Boolean. So the whole thing is being treated as a Boolean. Y, when it says Y, is Y greater than X, it's treated as a Boolean. Y divided by 5 equals to 2 is treated as a Boolean. So these are all Boolean values that are being compared. This has to come out to true for a Boolean value. This has to come out to true for a Boolean value. And when they are both true, then you get to the code block. Now, a good thing could be here was, let's say I say int, result, which is Y divided by 5. I do int result, Y divided by 5. Now I can actually use result here instead. Makes it a lot.
Oh, okay.
You see what I'm saying? So you can contract things out to variables to make things readable. It's like, oh, when I'm reading this code, int X is equal to 5, int Y is equal to 10. I take the result of Y divided by 5. I store that in a variable called result. And now wherever I want in my entire code, I don't have to keep doing Y divided by 5, Y divided by 5 every time I want to do Y divided by 5. Instead, I can just do result. What if I wanted an else if here? Else if this result is greater than 2, or else if this result is, just if for whichever case you could think of where it would make sense to use result again somewhere in the program, you don't want to have to just write code again. If you're writing code again, think to yourself, this is probably a good time to contract it out to a variable. Fair?
Yes.
So that's the idea. So we have less than, greater than, not equal to, or and. And I would say these would be, I would say, the most important for now. Or the most commonly used, right? And this is what we call a conditional branch structure. So these are, you can see why they call it branches, right? It's because it's sort of formatted in a branch-like way, and they are conditional, so you don't get to enter every branch. And of course, with these are the operators. So I wouldn't actually even call them operators. These are just, I believe they have another term. I don't think it's operators. I'll say that now. But these are nonetheless the ones we have. So this is more or less where you've been, I would say. Have you spoke about nested if-else statements or nested conditional branches? You got those? Okay. Yeah, I mean, the basic idea there is, look, I don't have to do this complexity where I'm looking at two things at once. I don't have to say if y is greater than x and result is equal to 2. Instead, I could just say, all right, maybe I'll check this later. Maybe I'll check the result equals 2 later. So I'll say y is greater than x. And now once I'm inside this if, I can do like another layer check, where I can say if the result is equal to 2, finally then I will print yes. You see what I'm saying? So you can actually decompose them and sort of put them into their own, and then you can actually keep doing this. I could say, well, let's say I don't even want to print that out. Let's say I want to have another conditional or another one or another one. And you can keep on nesting them in this fashion. And so that's the idea, right? So and of course you can have if else within them. But if you're doing that too much, it's a sign of maybe overcomplicating it.
Right.
So that's the idea, right? I'll go ahead and write the if condition else logic, if condition logic. This is just the basic template I'm saying, and you can manipulate this in whichever way you'd want. Logic. So this is just an example of the conditional type of, which I'll put here. Right. This is nesting. And I'm not sure why this gap exists here. Should not happen. Well, I will take care of that later. Really bothers me though, that's fine. So yeah, that's more or less the basic stuff. And we, let's see, data types, printing, concatenation, conditional logic, nested conditional logic. And I would say that's now more proper to cover methods. Or I could maybe write a program real quick and you could tell me what the output is. Or I could maybe also do a couple other things. So all right, so walk me through your thought process.
Okay. So we see that x is incremented and decremented, and then incremented in a way. So it would be 11, right? And since x is greater than 5, we can immediately rule out the other condition else. So we also know that x is greater than 3. So we know that it would print correct, right?
Mm-hmm. Exactly. So you just have to follow the logic through. Now, if x was equal to 20 here, or if x is greater than 20, what would happen?
Would print did not happen, right?
Yeah. What about failure? Is failure going to print?
No, because the initial condition that we have to meet is x is greater than 5, right?
Yeah, a lot of diffie Q stuff going on, right? Initial condition.
Right, yeah, yeah.
Exactly. It did not happen. So some people think that maybe if we're here in the else stage, we'll come out of it and we'll go into the last else. But remember, for any if-else pair, either the if will execute or the else will, right? Either the if will execute or the else will. And so if you're in the if and you're starting to execute things, it doesn't mean you're going to jump back out and go to the else. It's either or with if or else, right?
Right.
So good call there. I would say one thing that I probably missed was, if there's a string, let's say P1 for person one equals John, and let's say there's a string P2, if I write John here, will it give me an error? If I write the same string, will it give me an error?
Yes. Well, wait, can you say that one more time?
So if I were to write John here, exactly where I see P2, if I just write John again, will that give me an error?
No.
No, right? Exactly. What would give me an error?
If we assumed that P1 was equal to P2, right?
If I had P1 here, well, I can't,
Oh, right.
you know what I'm saying? So it's kind of like if you saw in basic math where they started to introduce functions and they said that, you can like they would map when they were covering domain and range, when they would map the y value to the x value, they'd say, well, you can only have one y value map. You can have one y value. You can't have one y value mapped to two x values, right?
Right.
Something along those lines. And so the variable names have to be distinct. Their values can be the same. There are multiple cases within which it makes sense to have the same values, but the same names. I mean, you can't have, so P2. Now, there's a problem here. The problem is if I say P1 equals P2, it will now add, it's going to judge, hey, is the P1 equal to P2, right?
Mhm.
And don't you think it'll print out true?
Well, others would say that it's true, but not us.
True. True.
Oh,
Okay.
wait, are they actually equal?
Well, yeah. See how they're,
Oh, I didn't know that.
yeah. Okay. But you really want to more or less use dot equals for this, and there's a reason for that goes into object-oriented programming.
Hmm.
And there's a difference between the equal check and the dot equals check. And I think when you get into, you have to understand objects in order to see, because in one case you're comparing objects, in the other case you're comparing primitive types, and we'll talk about that.
Okay.
But so that's the idea, right? I mean, this is basic programming, so you should be able to work your way around, stuff, right? So yeah, let me go ahead and give you a problem, and then we'll code it up, okay?
Okay.
So a good problem in this case might be where we have a program for a for an made by an engineer who is writing a program for a library, right? You ask the user their name, right? You ask the user their age. Now, if they are a teenager, being a teenager entails 13 to 19, or actually, you ask the user the cost of their book. No need for the name. You ask the user for the cost of their book. If they are a teenager, 13 to 19, right? 13 to 19, then they get a 1.50 discount. Okay.
Okay.
Just remember here that all books are at least $5. Okay. All books are at
Okay.
least $5. Okay. If they are a college student, we'll say that's from 20 to 25. Then they get a $2 discount. They're college students, right? They have more expenses. If they are from 25 to 30 and they have children, then give them the book for free. Okay. So go ahead and share your screen. I'll send you this prompt on Discord so that you can put it in your IDE and you'll work through it and we'll talk about it.
Cool. So I have a question.
Yeah.
If they're 25 through 30 and they don't have children, will they have a $0 discount?
If they're 25 to 30 and they have children, then give them a book for free. If not, yeah, sure. If not, $0 discount.
Okay.
But just think about this in the way that, well, if they didn't have two children, well, the program would take care of itself, right?
Right.
You know, the cost wouldn't change anywhere. So that is what they call edge cases. It takes care of itself. Just a thought there. So yeah, do you have your ability to share screen? No?
Let me check.
Okay, I'll just go ahead and do that here. We have participants and Jonathan. I thought your name was John. It's a lie.
Dude, I'm sorry I had to come out like this.
That's fine. We'll make you co-host here. Well, I sent you the prompt on Discord.
Cool. Should probably.
I'll stop sharing.
Cool.
What laptop do you have?
I have a. Okay, perfect. Sorry. I have I forgot what it's called. It's Dell.
Okay, nice.
So cool. I can share my screen. Perfect.
Okay, you're the teacher.
Cool. And let me find the prompt, or not the prompt. Ram, could you send me the
Prompt? Did I not? Where did I send that then? Okay, hold up. Oh, maybe I got sidetracked. There you go. There's the prompt.
Yeah. Okay.
So you want to make sure you voice your thoughts as you go.
Okay. So
If you want more
right
space,
now,
you can push this one to the side. This, you see the package explorer. So if
yes.
you hover over the edge, you can actually push that thing to the side. And you can even push the other thing to the side. And then so much so that you can reduce the screen a little bit. Yeah. Perfect. Yeah, sure.
Okay. So first, we're going to ask the user their age. In order to do so, we need a scanner for an input, right? And since it's going to ask us to import scanner anyway, we can just write this line out, right? Scanner user age equal new scanner. And this is, so we're creating a new object of the scanner class, right?
Okay.
Is that technically correct?
That is correct. So import the scanner, and then we'll talk about this one line. And then you'll write a small note here as to what the mistake was. And okay, you can go ahead and import that. So that's 99% correct. The only note that you want to write here in comments at the end of that line is the scanner object represents a scanner in general, not just for the age, not just for the string, not just for the, you can do that on the side. I think it would be probably better on the side because it'll get in the way of your code. Yeah. Scanner object takes input in general, not just for, one specific data. So here you called your scanner user age, right? You want to just call it a scanner or my scanner or keyboard, right? Or, scanner, or yeah, my scanner is fine. So it's for everything. It's not just for the age, right? You can use the same scanner for the string, same scanner for the age, same scanner for the cost. Okay.
Okay. And I mean, in this situation, would you get right into the prompts for the user, or would you create the variables first?
So if you think about it from top down, you want to first ask, then receive.
Okay. Input your age. Right.
Mhm.
Okay. User age will equal my next, and we're going to be using next int because an age is usually an integer. All right.
Yep.
Okay. Ooh.
Perfect.
And then ask the user the cost of the book. So
You can go ahead and do that. I'll just be right back. Because I need gushers to survive, John. That's how it works.
facts. Yeah. Input book.
Yep.
Let's put this here anyways, right? So this prompts the user for the cost of their book.
Exactly.
That's going to be my. So wait, my question is, do you remember when you said next line takes the entire line?
Yeah.
Does next int just take the next number?
Yeah, it takes the next number that the user inputs. So if they even put 5,000, I didn't say next digit only it'll take. I said the next number. So that's probably your point of confusion, right? The ints, you don't have to worry about this stuff. With the doubles, you don't have to worry about this stuff. Okay. That's a good decision, right? Keeping it a double.
Right. And my next question is, if it takes the next int, does it skip to the next line, or do we have to go?
No, you don't have to additionally have another, scanner there. It will go to the next line. In fact, what it does is it goes to the next line and then it takes the input.
Okay, cool. Okay, and since, okay, so if the cost of the book is less than $5, we should we, okay, should we prompt them again?
Don't worry about that part. That's going to require loops.
Right.
I'm going to teach you loops after this. But,
okay.
But think about it in this way, just for the learning purpose, is if we enter a cost that's not at least 5, we're going to make them do it again. And we're going to keep making them do it until they enter a cost that's 5.
Right.
We're going to get into loops. That's a whole other topic.
Okay.
But now assume all books are at least 5.
Okay.
Don't worry about that one.
Cool. All right. If they're a teenager, so we're going to do if, right? Oh, wait. Okay, wait, we're good. If user age is less than or equal to, no, if user age is greater than 13 and your age is less than or equal to 19.
Yep.
Okay, so that's good. Book cost plus do to $1.50. Okay,
Exactly.
so if user age is greater than 19 and user age is less than or equal to 25.
Yep.
So for college students, is it 25 inclusive?
Yeah, we'll say 25 is inclusive.
Okay. So for parents or like
Well,
adults,
well, actually, if they're in college, it's from 20 to 25. I know that that's not true in practicality.
all right.
We're just setting up a boundary here. So both of these were on both bounds, it would be inclusive. You'd be a 20 in college, and you could be any age between 20 and 25 itself. So you can add that inclusive there.
Okay. Okay. Book cost equals is 2.
Yeah,
Whoops.
this is what they call, have you heard of camel case notation?
No.
So the way that we write variables in Java is we use camel case notation. So you see how each variable name that you write, first it starts off lowercase, and then if you want to add another word, like you started off with book and you wanted to add another word, you jump to uppercase. So you're going lowercase and then you immediately jump to uppercase, and it's kind of like a hump, which resembles the back of a camel. So they call this camel case notation.
Cool. That makes sense. All right. So whoops. Let's user. So for non-college students, it won't include 25.
You just go ahead, change that requirement to 26, you're 26 to 30. So we'll just change the prompt down there.
26.
I don't want you to have to worry too much about these, like including the bounds or not. This exercise is about taking input and conditional branches and variable names.
To 30. Would this be where we prompt them to ask if they have children?
Exactly.
Okay.
So you really want to think through this one here as to how this is going to work.
So let's say William has children.
Yep.
Oh,
No, you're fine.
well,
There's a difference, but the equals can only go in the if statement conditional things. There are two things. There's a comparison operator, equals when you're comparing two things. And then there's something called the assignment operator when you're assigning something. That is equal, singular. I'll write that in the notes.
and so when we ask them, are they, let's say they say yes or no.
Right.
Should we include another? Well, I'll try to explain. Yeah, so when we use this, their input, they're going to input a string for this, right?
So, we don't really, we don't really want to, like, right now for at least, because when they input a string, they can either say yes or no, right? But guess what? If they put yes, all caps, and you take into account the lowercase version, you're gonna you're gonna flag that as no, that they didn't say yes. You see what I'm saying? So if in your if statement you say if the response has children is equal to yes, but your version is lowercase, their version is uppercase, or maybe their version is a mixture of uppercase and lowercase versions. So you're gonna have to take that into account somehow. But or maybe they don't do yes. Maybe they put yes and then some random character at the end. These are things that you don't want to really deal with right now. Just have them say, press 1 if you have children, press 2 if you don't.
So should this not be a Boolean then?
Yeah, exactly. Yep. And again, I mean, I didn't specify that in the prompt, but we're here and we'll work with that.
Oh wait, whoops. Do you have children? 1 equals yes.
2 equals no.
2 equals no. And then we would do a nested if. So yeah, we would do if has children.
Yeah.
Equals 1.
Benefit of the nested ifs are immediately apparent, right?
Right. Yes. What cost equals 0? Okay, this is incorrect. Else if has children equals 2. I mean, it'd be kind of redundant just to put book cost equals book cost, right?
So could you go down 1 second in the prompt? So if they have children, and give them the book for free. So when I say that, like, oh, do you have children? And then someone says, yeah, I have 1 child. So, at least 1, right? So you just say you have 1 child, right? At least if you have at least 1 child, then you have children. Now that's not something you have to take into account, like, oh, how many do you have? If you have at least 1, then you either have 1 or you have many. Right. In both of those cases, it's fine. So if has children is 1, set book cost to 0 and leave it at that. And if has children is 2, exactly, it's redundant to say else if book, and I think we talked about that, right? When we were writing the prompt, it's redundant because book cost will be whatever book cost was up until this point, right? Whatever book cost was up until this point, we don't have to set book cost equal to book cost. By this point, book cost is what book cost is, period. So you're right. You can just remove that entirely.
Okay. Cool. And then should I just display the cost of the book?
Yeah, sure. Or actually, to practice concatenation, say your age was, add their age, the cost of your book was, add their, and just say book cost, yeah. Your age was, yep. Exactly, yep. So you're good with concatenation, I would say. Yeah, and then we'll do damage control if necessary.
Cool. Put my age. My age is 19. My book costs $5. Cool.
Yep, you got the discount because you're a college student. Now let's see if you were a mom.
Right. Okay. That's what your book was. Sorry, this is
Mhm.
put your age. I'm a mother of two, so it's gonna be, I don't know, 28. $5. You have children? Yes, I'm a mother. The cost your book was.
So what happens sometimes is you write the program in the way that you wanted to, which you've done now terrifically, but sometimes people will come up to you and say, look, you're missing this, or we want it to be more robust in this way. So now if I approach you, I say, look, John, you've written code, so be it. But for people who are above 30, you do absolutely nothing. At least tell them that. Tell them that your age is above 30 and you'll receive no discounts whatsoever.
I guess. Should I just, so I'm telling the user that if they're above 30, they'll receive 0 discount?
No, I'm saying they have to enter their age. And then if their entered age is above 30, you don't want to tell them in advance, like, oh, if your age is above, it's not like an announcement. It's just that if they enter an age above 30, they must be told that there are no discounts.
Okay. So what I do in this case, would it be, so it's specifically above 30, right? So wouldn't else if be redundant, or should I just go with the
Are there more?
else?
Yeah,
So an else if would be redundant?
exactly. And else if would be redundant. Else if is all other cases. You want to paraphrase else in your mind, you want to think of as all other possible cases. Now, for the context of the scenario that I've described, it makes sense that all other cases is in fact being above 30, right? Yep, you'll receive no discount. Now, yep.
Let's say 47. $5. I don't know, let's go $7.
You'll see here the cost was $7, right?
Cool.
Now, suppose I now come again and I say, look, dude, if there's no discount, well, I guess we'll just leave it at that. That's fine. We'll just leave it at that because this is I want this to be like a beginner program you can refer back to. I don't want to, complicate it more and more by adding additional pieces, but this is good, right? This is good. And now we can go over, I mean, if you have time, I can go over loops. And we can sort of do this if you'd like.
Yes, loops would be cool.
Okay. So do you have a general understanding of loops, or?
Yeah, so I have a general well, I know the very basics. I don't know the difference between while and for
Okay,
loops.
no problem. So this will stop other screen sharing. Do you want to continue? I'll go ahead and say yes to that. Okay, so yeah, good job on that one, honestly. We'll talk about loops. So, it all starts with this. So all loops in particular, they're called repetitive statements. Statements that you can write in code that can inspire some type of repetitive motion. And we have predominantly 3 loops. So the for loop, right? The while loop and the do while loop. Okay. Now the for loop you use in a case where specifically, how many times the loop must execute. if you know that you have to execute something 3 times, use a for loop. If you don't know how many times, like for instance, if I want to take a number and compound it 3 times, I could use a for loop. I could also just use basic arithmetic. For an example, if I wanted to take a number, I wanted to add some number to it 3 times over using a loop, I'd use a for loop because I know that I have to compound it 3 times. That was in the instruction. But what about in cases where I don't know how many times I want to repeat a loop? For instance, you know, in the program we were just doing, if they don't enter a cost of a book that's at least 5, I want them to keep going. I want them to continue again and again and again and again until eventually they enter a cost for a book that's at least 5. So you see what I'm saying? So in that case, it makes sense. Like, hey, I'm going to trap you in this loop until you enter a value that is at least 5. So I'm going to use a while loop. While you don't enter a value that's at least 5, keep going in the loop. For is for how many times, and then you specify how many times. For how many times you want to do something, the loop will do it that many times. While is, well, while it's not true, keep doing it. Eventually it will be true, and you'll break the loop. Do while is exactly like while, but there's a key difference here. A do while will execute at least once. So I'll write this here for the while loop at least. So for the for loop, you know how many times it'll execute. For the while loop, you don't know how many times the loop should execute. Now, the thing is, sometimes do while is you want it to execute at least once. And we'll talk about that third edge case. Now, the while loop and the do while loop are interchangeable. All while loops can be written as do while loops. That's just sort of more of a nuanced point. But these are more or less the 3 types of loops that we have in Java programming language. And actually, you'll see that there really aren't, I haven't come across any more, well, I have in Python, but in general, for, while, do while, these are sort of the key main. Okay, let's talk about the for. So suppose I had a system.out.println and I wanted to print out hi. Let's say I wanted to print out hi. Now I could print out hi 5 times over if that was my goal, but instead I know I want to print it out 5 times. Why don't I just use a for loop? So a for loop is, this is the structure of a for loop, some number here, I++ logic. Now let's dissect this a bit. Int I is equal to 0. This is a value that is going, this is kind of the fuel for the loop. This is what it's going to make it run again and again and again. I is less than some number. So I like to think of it this way. This is the template for a for loop. And however many times you want the loop to execute, put that number there. I want this loop to run 5 times, put 5 there, and you'll see that in my logic, it runs 5 times. So that is a higher level understanding of a loop. Like, hey, if I memorize for and then all this crap, and I just know that if I want, how many times I want to execute, is it right there? The loop will execute that many times. So if I had put 3 here, then it would have ran 3 times. But what's really happening? What's really happening? How is this actually working? And the idea here is, and I'll go iteration by iteration. So first iteration, I is equal to 0, isn't it? I is equal to 0. It prints out hi. So we have 1 hi on the console. Now, what happens? So we go like this. It comes up here. It says I is equal to 0. Is I less than 3? Yes, it is. I is 3 because I is equal to 0. And then it will print out high. And it has already by that point incremented I by 1.
Mhm.
Okay, so now when it comes up the next time, I is 1. Second iteration, I is equal to 1, right?
Right.
And then it prints out high again. On the third iteration, I is equal to 3. So in the first iteration, I is 0, it prints out high. Second iteration, I is 1, it prints out high. Third iteration, I is 3, it prints out high. And then when it comes back up again, I is now equal to 3. It's not going to continue. I needs to be less than 3. It cannot be equal to 3. So the Boolean condition is falsified. We break out of the loop. Do you see what I'm saying?
Mhm.
So
Yes.
this variable helps us keep track. And I plus plus constantly increments. Eventually in that incrementation, this will be falsified. Because eventually that's what happened. It got to this point where I was equal to 3, or sorry, I is equal to 2. Sorry, this is on the third iteration. So you see 0, 1, 2. So we started here. So we started here, first iteration, I is equal to 0. We printed I. Second iteration, I is equal to 1. So this is the top-down approach. So we looked at it, we said I 0, is I less than 3? It is less than 3, it's 0. Increment I by 1, so now it's 1. We print out high. We come back up again, I is equal to 1 is this time because we've incremented it. Is I less than 3? Well, of course, 1 is less than 3. We print out high. Then we come back up again after incrementing I is 2 this time. And it says, is I less than 3? That's true, it is less than 3. 2 is less than 3. It increments I by 1 again, prints out high. Then it comes back again, and now I is equal to 3, so it stops. Do you see what I'm saying?
Yes.
That's usually a confusing thing at first, but do you understand that more or less?
Mhm.
Okay. So that's kind of the idea is each time before it comes into the loop, I is going to increment by 1 each time before it comes in. And then eventually when it works its way back up throughout that process, eventually what's going to happen is the condition will be falsified. The initial condition will be falsified. And when that's falsified, you'll break. So I will eventually reach a stage where I is no longer equal to that, no longer less than that number, and then it will be falsified. So that's the, so I could do 10 here, right? Multiple highs. I could do 100 and I get the same idea here.
Can we do 13 billion?
There is a limit, I believe, on the, so there's a limit, I believe, of the number that you can input in Java, and that number, I believe, is far, far lower than 13 billion.
Well, I just don't think I'll be able to understand the concepts unless we
Do it 13 billion times. So yeah, that's the basics of the for loop. Now, you have to understand that in the for loop itself, you can have code, right? If else actions and so forth, right? And we can see this happening. So if we say int x is equal to 5, and I say x plus plus, right?
Oh, wait, can we do like a conditional to only print out like the even?
Yeah, even numbers.
Yeah.
So with even, so there's another operator I had not introduced. It's the modulo operator. Now the modulo operator gives you it's like division,
Mhm.
it gives you the remainder, right? So if I say, and we'll talk more about the modulo operator, but if a number is even, then you must be able to take that number, let's say 4, modulo 2 equals 0. This must be true, because if I do 4 divided by 2, the remainder should be 0.
Right.
So this means a number is even. If I can take that number and module it by 2, and that will equal 0, then you see what I'm saying? Why couldn't I have just done this?
Because that won't be 0. That won't yield the remainder, right?
Exactly. So any even number, if I divide it by 2, the remainder will be 0. So if I take 10, this is true. If I take 16, this is true. If I take, whichever even number, and if I divide it by 2 and I get 0, that means it is in fact an even number, right? So I can take, whichever. So I leverage this fact and say, if I modulus 2 is equal to 0, system.out.println I. So all even numbers of I will now print. We'll see this in action. 0, 2, 4, 6, 8. Now, just as a point of formatting, if you didn't want them vertically, you could have them horizontally displayed as well. System.out.println prints an additional line for you on each print. You can opt out of printing a line by removing the ln. And when you do this, you'll get all the numbers more or less together. So, which is not actually what you would want. You see how now they're squished together? So what you could say is you could just add this here, and then that would solve your problem. 0, 2, 4, 6, 8. Right?
Cool.
So yeah, so that's the idea. So if else and everything you could imagine can be within the for loop, right? So this is the structure of the for loop, and I'll put this in the comments here. This will be the number you want, number of times. And of course, I could say int number of times equals 5, and then or I can let the user enter that in, and then it will perform the logic. You see what I'm saying?
Yeah.
So I'll put this here, and then we'll talk about the while. Right. And you can, make the notes a little neater later, but now the while is a little interesting because let's say I had int x equals 0, while x is not equal to 5, not equal. What's going to happen here?
Would it be an unending loop?
Yes, it will be an infinite loop. See how I'm generating infinite not equal statements? I need somehow to solve my problem. How do I do that?
Would we increment x?
Exactly. If you increment x on each iteration, eventually you'll falsify it, right? Think about it. So x was not equal to 5 here. You printed it out, not equal. But then you incremented it. Now x is equal to 1. Still not equal to 5, you printed it out. But then you incremented it again. Then you came back up, still not equal to 5. Printed it out. Then you incremented it again. Then you kept doing that, and eventually it was equal to 5. So instead of coming back and doing all this nonsense again, you came out of the loop. You came out of the loop. See what I'm saying?
Right.
You sure?
Yes.
See, think of it top down,
Wait,
right?
could you say that question one more time?
Look, so x is not equal to 2, right? So now we're doing it with two,
Right.
only two iterations. Now, you have to think of this as a loop. So you come down, and then as soon as you reach this endpoint, you come back up.
Right.
Come back up until this is falsified. So it says while x is not equal to 2. Is x not equal to 2?
It's not equal to 2 just yet.
Right? Because it's 0. It started off as 0. So you printed out not equal, and then you did x plus plus. Now now you come back up. Now what is x?
It's going to be 1.
1.
Right?
Is this true or false, this statement?
That's true.
So you came back, you said not equal. Then you did x plus plus again. Then you come back. Is this false now?
Yes, it's going to be false.
Well, when you came back up the second time, it was equal to 2.
Right.
Right. So this statement is true. Or sorry, it's falsified. Right. In which case you're right and you break. So that's the idea. You keep going up and up. You keep going in repetitive loops till the condition is falsified.
Cool.
Okay. Hopefully that makes sense. I mean, I know it's a tough thing to grasp initially with loops, but you kind of get what I mean, right?
Yeah.
Are you sure you're positive?
Yes.
So is x not equal to 2? You come not equal, increment, come back up. And now it is equal to 2, so you fall. You're right. First it's 0, you print not equal, you add 1 to x. Now it's 1. And you come back up again, you check, is x not equal to 2? Right, so that's the idea. So it's this circular motion thing that you keep getting trapped in until eventually you put the right answer. And we can see this scanner, my scanner equals new scanner. And we can see that if I say int x is equal to my scanner.nextInt, and I have them take it in, I can basically trap them. I can say system.app.println, your input needs to be 2. Right? Your input needs to be 2. So I'm sort of trapping them in this sense. And then I have them x equals my scanner.nextInt. I have them do it again, I believe. We'll see how this pans out. Oh, so what's my problem here?
We didn't initially prompt the user, right?
Exactly. Your input needs to be 2. Gives me another opportunity. Nope, your input needs to be 2. Gives you another. Nope, you see what's happening until I enter 2. And then actually, if I wanted to thank the user for entering 2, where could I do that?
Would we do it after the while statement?
Yeah.
Or the while loop?
Yep. Finally entered 2 is what I. Okay, all good. So with these loops, all good with these loops. That's the idea with these. Okay. Is that fair?
Yes.
What's your proficiency on methods? Or do you know what an array is? I'll say, like, what's more compelling for you to learn, methods or arrays?
Well,
Arrays.
I mean, I think I'm okay with, I forgot what they were called, one-dimensional arrays or two-dimensional
Yeah.
arrays. I forgot which
Forget
one.
about 2-dimensional arrays for now, but you know about arrays,
Yes.
but very well.
Yeah, I know about indices and everything like
So-
that. I know about looping over an array.
Okay. So I'll just go through it very, very quickly because it's on record.
Oh
so-
yeah, for sure. For sure.
So the array is the array is a data structure. It is the most basic data structure in Java. And I think you froze, John. I think maybe it's your connection. Can you hear me?
Yeah, I can hear you. Can you hear me?
Yeah, I can hear you. So an array is the most basic, and you can watch this again if I'm going too fast, but an array is the most basic data structure in Java. It is of static allocation of memory, which means that after you declare the array, you cannot redeclare the size. An array list is another type of data structure that does not have a maximum capacity. You keep adding on to the size. With an array, it is static allocation of memory. Once you allocate the memory to the array, it is fixed. It goes into memory and it allocates that many spaces that you would need. And then it expects values in those spaces or none at all. So the idea here is that the declaration is you write the data type, then you write the brackets, then the name of the array, name of array equals new data type, and then size. So how does this format work? How does this format work? This format works in the following way, where I say int, that's my data type, name, my array, equals new int, size, 5. What has happened? What has happened is I have allocated 5 slots in memory, 1, 2, 3, 4, 5, and I have also indices are associated with each of these boxes, 0, 1, 2, 3, 4. So it is offset by 1, which means that the indices will start not from 1, but from 0. So I have int my array, and in the same way, by the way, you can declare the array and then you can initialize it later. My array equals new int. Same way that variables work. Or we could revert back to the following more conventional way of declaring and initializing at the same time. As far as the size is concerned, you can introduce a scanner. My scanner equals new scanner. System.in, and you can int size or user choice or user size equals new or my scanner dot next int. And you can actually take in the size as they would want it, and you can pass this as a variable. Fair?
Fair.
I'm just saying that as an option, but so this is declaring and initializing an array, which means declaring and initializing. How can we actually populate? This is the term that they use, populate. How can we populate the array? The formal way of populating an array, manually at least, is saying that name of your array, or name of array, index you want, equals value you want. So the name of my array was my array. Now I refer to the index within which I want to put the value. My array, let's say within the first indice, equals, or let's say the first is actually 0, equals 1. And I can duplicate this process, and I'm going to actually reduce the size of this array to 3 for the sake of simplicity here, which means my maximum index count is 2 because I'm offset by the length, the array.
Right.
So 1, 2, right? Let's say I have 100 here, 200 here, 300 here. Since you already know how to declare, so now if you could have seen the array, you'd find that the array boxes are filled with the values that I've ascribed them to. However, I will say that there are properties on the array, properties on an array. Properties go as follow, where you have one property, which is the array name dot length. This is how many boxes you have. which also you can think of as elements. Okay, so if I do system.out.println and I say myArray.length, you'll see that I actually, let's see what's going on here. Array.length. Oh, okay. So what's happening now? Why haven't I seen anything on the console? Good question.
Is it because I have no idea?
So it's waiting on the input. See, it's waiting for me to type something. Top-down approach. First, I registered the scanner. Then I said, hey, ask for an integer. If I remove this, that won't be a problem. See what I'm saying? It was waiting on a value for me to input. Now it's printing out the expected.
Oh, okay.
So you have to, when you look at programs, always go top-down to read for bugs.
Okay.
Okay, so I registered a scanner first, then I registered the size. Now I registered the array. But before I did that, before all this logic here, I asked the user for size and the system was waiting on that size. So I've removed that since, and now we're fine. So I declared the array, I attributed the size 3. I went through each indice value I went through, and I ascribed a value for that place in memory. Then I printed it out. Or I didn't print it out, I just printed out the length of the array. So this property exists where you can reference the name of the array. And if you do .length, this is an attribute on all arrays. You find out how many boxes there are. Right? If I do -1, I'll get the maximum count of indices. Because remember, if I have 5, so let's say I have 3 elements, 0, 1, 2. So that means the length of the array -1 is the maximum amount of indices I have. You see what I'm saying?
Right.
I have 3 elements, but my indice count does not start at 1, 2, 3. My indice count starts at 0, 1, 2. So a law of arrays is you can always take the length of the array, subtract that by 1, and that will be your maximum indice count. Right? See what I'm saying? So this is going to show, what is this going to show?
This is going to show 2.
Right? Okay, perfect. So that's the idea there. And so there's these are sort of the main points. Now, suppose I wanted to, and of course, I'm not going to note them down for the sake of time, but they're in the recording, but we can iterate through the array and I is equal to 0, I is less than. How many times do you want to iterate? Well, you want to touch each element, don't you?
Right.
So remember what I said back when I was talking about for loops. I said, put the number here. The number here should be how many times you want to iterate.
Right.
So how many times do you want to iterate?
3.
3. But what if you don't know the size of the array in advance?
We would do myArray.length.
Exactly. You don't know how many things they've chosen to add. So myArray.length, system.out.println what?
Would it be myArray brackets I?
Yes. It will first go to myArray of 0, it'll get 3. MyArray of 2, 1, it'll get 200. MyArray of 2, it'll get 300. So when you do this, you get 100, 200, 300. Oh, is that fine?
Yes.
So again, I mean, this method is in the video. You can make a note of that later, or I'll just add it here. But and again, I mean, I have each of these notes in like that dedicated Java notes Notion page. So all of this is already documented far better than I could do so now at the end here. But there's a different way of iterating through an array if you want to touch each and every element. It's called the enhanced for loop. Or you can ascribe a name to each element. You can call them elem. You could call them obj. You could call them number or num. Int num is with a name you're going to ascribe to each element in the array. And you can say for each num in the myArray array, print out num. That fair? So you see how I still get the same result. So the int num aspect is ascribing a name for each element as you pass. And my array, the second part of it is of which array do you want to do this for? So for each num in my array, print out num. Not crucial, but sometimes there.
Cool.
So, so tell me this, how would you write a program if you wanted to print only even numbers of this array, my array?
So I would do 4 and just using a normal vanilla for loop.
Yeah.
Yeah. My array dot length I plus plus. So I would do if I modulo 2 equals 0.
Okay.
I would do right, I would print out the element of that array with that index. So I would do my array bracket I.
Okay, so what's wrong with this code? There's something wrong. Tell me what that is.
If I
remember what the prompt was, print out only even elements that are within the array values.
Right. Oh, not with even indices.
Okay.
So if my array I modulus 2 equals 0.
So that's the correct one, right?
Right. Oh, and they're all even.
Yeah. And so in which case we'll just make this 109. Well, we should only get the latter two, which we do. So that's fine, right? What's an optimization we could make? And this you'll see often. In fact, you might not, but I'm just telling you this is possible. You could store the value in advance. You could say val is my array of I. Right? Say val instead. And you just put val here, and you see how that works? Instead of saying val of I, you could just say val.
Oh, yes.
It's a little better, right? I mean, you might not see it often, but it helps to know that you can actually do that. Int val, my array, you stored that. Why do this my array of I again and again? Right? Just say val.
Right.
This is the value grown. So that helps. Yeah, so that's the idea. Let me go ahead and cover methods. Are you aware of methods?
Yes.
Okay.
A little bit.
I'll ask you this do you have time to cover methods?
Yes.
Okay. So I'll cover methods. Great. So like I said, these these notes, you don't have to worry about losing these notes. I have them in the same order they appear here. But let's talk about, so how familiar are you with methods?
I'm gonna respond to that with an emoji.
Okay, fair.
Did you get that?
Let's see. Oh, in Zoom chat or
yes.
Chat. I actually didn't get that. That's awkward. That is weird.
Give me 1 moment. I'm gonna put a quizzical expression
Oh, there it is. Okay, so you don't have that much of an understanding on methods, right?
Right.
Okay, and that
That's my emoji said.
yeah, yes or
Sorry,
no?
okay. Okay, let's get serious. Okay.
Okay, but do you, I mean, do you have at least some, just so I know how deep to cut?
I've used them a bit before, but I don't know all of the
Okay.
nuances.
So think of
Yeah.
this. Think of this, and we're going to create a calculator right now. That's the goal. At the end of this, you
Okay.
should know everything to create a calculator. So the idea here is with methods, right? So what happened, or what used to happen, and this is way back, way even before 2000s. Well, they used to write something called spaghetti code. Spaghetti code. Spaghetti code is code where they just keep writing code linear fashion, linear fashion, linear fashion. And once you do that so much across so many different files, eventually you begin to understand this is highly inefficient. And it's highly inefficient because there's no organization. You don't know where to start. Everything is so interrelated and it's so complicated that you can't read it and you can't debug it, and it's hard to even write code like that. So what they decided instead to do was to break things, this longer segment snake of a code, or which they call spaghetti code. They decided to take pieces of it and isolate logic into little packets, or what they would call modules. So they would bundle up a function. They would bundle up a function. Let's say I wanted to create, I could create a function just to add two numbers. I could create a function just to subtract two numbers. So they would modularize their logic into different segments, modules, or areas. All of those mean the same thing. And then they could call on that logic whenever they want, wherever they needed. And so that's the idea. So any large, sophisticated program is just a collection of smaller methods. So it's like, if I want to complete, if I want to have, if I'm looking at, okay, my program asks the user for a cost, as we had done before. But I'm going to create a method. That method will only be responsible for asking a user for a cost. That way, if there's a bug in my code, I can narrow it down. If there's a problem with asking the user for a cost, I can go to that method and I can say, hey, all the code I have for asking users for a cost is here and only here. It is not going to affect every other thing that I have in my program, because that's what happens sometimes. You change one thing, and down the line, you'll find that 10 other things will change. And then you're going to keep going through this rabbit hole that's infinitely dense, and it'll be hard to distinguish between what the error is and what isn't. So modularization allows us to separate our concerns, and that's kind of how it works. So let's say I wanted to add two numbers. Right now, I'll do this way, where I have two numbers and I'll basically just add them here, where I'll say system.out.println add, right? And again, or you could say maybe answer is equal to 5 plus 10. Then print out answer instead. So this is semi-efficient, and but what if now I wanted to, now I'm going to introduce adding a scanner to it, then I'm going to introduce subtraction, then I'm going to introduce multiplication, then I'm going to introduce division, then I might even introduce a function that can take the numbers and raise one number to the other so that I get like an exponent. Right. So this is a problem. Once I do that, eventually I'll have dozens and dozens of lines of code, and it's going to look like what? Spaghetti code. I don't want that. This is the solution to that. The solution to that is a function, or the function. A function works in the following way, where we have a access modifier first. Don't worry about this too much. When you get into object-oriented programming and you start working with different files, you'll begin to understand that sometimes I don't want code available to every file. So for now, at least, access modifier. Then either static or non-static. And again, this is something we'll talk more about when you get into object-oriented programming. A lot has to just be assumed with Java. Access modifier, static or non-static. So, and then the return type. What does your method, what is what is the expectation around your method? What should it return? And the return type. Then the name. And then the parameters. And then finally, the logic. Okay. So create a function to add two numbers. Access modifier, for now assume public is a safe bet for everything you do. Public, assume static is a safe bet for everything you do. In the same way it was a safe bet here. Public static, when I add two numbers, what return type am I expecting?
Either a double or an integer, right?
Okay, so we'll say int.
Okay.
The name, add two numbers. Parameters. What should my parameters be? Int num1, int num2. There, that's fine. Now, it's giving me an error because if I have said to it that it should expect a return type as integer, it has not gotten that. It's not satisfied. It'll keep giving me the error. So for now, int answer will be what? Num1 plus num2?
Right.
Return answer. It's happening.
Okay.
So this is a very, very basic method. And you'll see methods more or less in different programming languages. The concept is the same. Let's say you're learning Python. Python will have, it'll say instead of public static int add two numbers, it will say def define, and then add. You don't have to do data types in Python. X, Y. Instead of brackets, you do indentation, and then you say return X plus Y. That is, see, that's why they say Java is so hard. Python is just this.
Yeah.
JavaScript. JavaScript is function. Add. X, Y. Return X, Y. So it's clearly a lot better to learn Java, and it's very hard from going from this to then learning all this nonsense. So like, you can go from Java and then you can pick up Python very fast. It's like, oh, in Python, all they say is definition, and then they don't even declare the types, and they use it.
Yeah.
So you see what I'm saying? But this is more of a rigid structure. And now, so you've declared the method. You've declared the method, you've added the parameters, you've added the logic. Now there's something called a method call. The computer has to call on the method. So how do we do that? We'll say add, and we can pass in two numbers. Add 5 and 2. Int x equals add, add two numbers. So this is fine. It's fine. And I can take this, I can store it in a variable. I can take this, I can store the result of it in a variable. And then I can print that out. See how I get 7? Now, I don't have to write code again or do whatever. I can just pass these numbers out, and it works. 15, right? Int first number equals new, my scanner dot next int. Maybe I'll ask them here to, enter the first number. Enter the first number. Okay. And I'll duplicate that again. I'll say, well, go ahead and enter the second, right? Enter the second number, and that will be, second number, my scanner dot next int. And then instead of passing 10 and 5, I'll let them pass the first number and the second number. Right? Then I'll enter the first number 5, enter the second number 2, I get 7 as a result. Now, let's say I want to create a method that will display the result to them. Well, I'll just say public static int this, or not int, because I'm not going to actually return anything. I'm just printing something out. Printing something out is not the same as returning some things. So, or this might be a little too necessary because it's not that much work to print things out. But you get the idea. Now, can you add, so this whole thing would be the same for what? Well, if I wanted to subtract, all I have to do is subtract 2 numbers in num1, num2 minus. If I wanted to multiply, I could say multiply 2 numbers, right? Multiply 2 numbers. And then here I'd just say dot. And then in fact, I'll just, I'll say here, I'll say, well, what do you want to do? I'll say, if you want to, 1 for subtract, 2 for add, 3 for multiply. Okay, 1 for add, 2 for subtract, 3 for multiply. And then I'll take their option in option equals my scanner dot int. And if that option is equal to 1, then which method do I call? Which method?
The subtraction.
Exactly. So at first their result will be 0, right? And if they pressed 1, that means their result will be the result of add 2 numbers. This process is then repeated, else if, you could say, else if the option was equal to 2, then in this case, it would just be subtract 2 numbers, right? Else if the option was equal to 3, it would be multiply. And then finally, your numbers were one for subtract, 2 for add, 5 and 2, I get 3. So why am I getting 3 here? Because maybe the logic for 1 is calling subtract, or 2. What did I selected 2, it's calling subtract, right? So this is wrong. It should be 1 for add, right?
Right.
For multiply. So that's the idea. Now I have freedom to say 1 and 5. Let's say I want to multiply them. I get 5. See the idea there?
Yes.
So yeah, that's the sort of the basics of modularization. Of course, suppose I didn't want users to, I didn't want them to enter, like I prohibitly don't want them to enter 5 as one of their numbers, right? If num1 or num2 is 5, if num1 is equal to 5 or num2 is equal to 5, return -1. Can't have them. Now, after you return it, you're going to send it back up here, and you're never going to come back in this method. So you're not going to jump out. When you return, you break out of the method permanently until it is called again. So if I were to go here and if I were to say, enter the first number 5, second number is 2, or if I say 1 for add, well, one of the numbers were 5, so -1. That's a problem. You see what I'm saying? Okay, so now an exercise for you. Are you tired, or you want to do an exercise?
Yeah, I can do an exercise.
Okay. Create a method. If I taught you enough to do that, program should ask the user for how big they want the array to be. Or yeah, I'll just say create a method that receives an array and adds up all the even numbers within the array and adds the result. And let's see. Yeah. Create a method there. Yeah, I think that's fine for now, I guess.
Cool.
So you have to have a method to do this, and it has to communicate with the main method, okay?
So, can you see this?
Yeah.
Tutorial. Create a new class, right? Just cause.
Yep.
Call it tutorial. Tutorial 2. Okay. We're gonna make the main method. String. We know this. But we're gonna save that for later, right?
Yeah.
So are we taking any input from the user or?
Look, do you think that you can, well, so why I hesitated to do that was because let's say they enter 5, right, as the size of the array. Do you think you're able to use a for loop to have them enter in each value? Try it out. Let's try that out. Okay.
Okay. So scatter equals now. System.in. Okay, so we're going to import the scanner class. We're going to create a scanner from that scanner class.
Yeah, the java.util, there's a utility class in Java for the scanner. So that's what the dot notation is referring to, java.util.scanner. It's a part of the class.
Okay, so we're going to do int array size equals my scanner dot next
Yeah.
integer.
Mhm.
And then we should probably prompt the user, right?
Right.
How large would you how, how large would you like how large would you like your array? Okay. Yeah. How long would you then we're gonna do how do we array? I don't know, semi array.
The first, the data type.
So would it be array?
The data type of the elements you want the array boxes to have. Yeah, then a bracket symbolize, and then your name, the name of the array, not John. One second.
Equals,
You work on that, okay? 1 second.
size. Mhm. What does this do? That's right. Just do this.
Sorry about that, John.
That's cool.
Yeah. So remember int here, you want int to be here. Just type in int where your cursor currently is at or blinking. Yeah. And then let's see. Array size. 1 second. It's totally static. Scanner. Scanner dot next. Int. Insert dot class to complete expression. Could you send me this code on Discord real quick? Let me put it in my.
Yeah.
We'll left out the I there. So. And in the meantime, try to see if it's wrong. Yeah, then it has to be my array. So you're, I believe at the end there, I believe, let's say, no.
I think I forgot the new keyword.
Yeah, the new, yeah, new int. Yeah, it's easy to forget for sure.
Yeah. Okay. And
Yeah.
then 4,
Yeah,
0. While I is less than array
size, yeah.
I plus plus. So this creates a for loop that
Yeah, so this for loop is going to actually populate the array for the user. So what's going to happen is you first want to ask, think about what that process will be. Think.
we're gonna do populate array.
Mhm.
Whoops. And then we're going to do let's do my array I equals my scanner dot next and
Right.
oh, but it should only be the even.
What's that?
Oh wait,
You're right. You're right here. You're
okay.
right. Because
Where-
whatever you enter will be put in that position, array, my array of I.
Okay.
But you want to ask them first, right? So I know you asked them up there, right? You just said populate array, but it's not going to say that 10 times, is it? It's only going to say that once,
Right.
right? So we can remove that print statement, put it inside the loop, and say enter value for, let's say index I, right? Maybe.
Index plus.
Right, plus I. Yeah, that works. Well, before you run it, go ahead and print the array afterwards. After this for loop, go ahead and actually make a method to print the array. Don't do that here.
Okay.
Make a method to print the array. Again, we're trying to isolate our logic, aren't we?
Yes.
Okay.
So
It'll just be
that's
void. No, it'll just be void. It's not
Okay.
printing out something. Printing something is not actually returning things. Go ahead.
okay. And I should still name it though, right?
Yeah, you could call it print array or whatever. Display, sure, display array.
Yeah.
Now it's gonna tell
Um,
you what.
It's going to be taking an array as an input, right?
Yeah, but remember data types, yeah, and then you can call it whatever you want here. You have to give it a name. Remember, int has to have a name. It can be a placeholder name. Dummy array, you can call it. Because it doesn't have to match. It's a placeholder.
Right. Okay. New system dot. One.
So
Would
it's,
we-
yeah, so it's not possible to do this. It's possible to do this in Python and JavaScript, but in Java, you actually have to iterate through each element of the array
Mhm.
in order to get each value, okay? So you'll need a for loop in there. So you'll actually need a for loop in that display array method.
Okay. So I'm just gonna see if everything works. Just real quick.
It will print out an object, a memory location for the array, but not the array itself.
Okay. So,
Uh-huh.
oh, okay, I see exactly what you mean.
No, go ahead, try it just for a learning experience. Just go ahead, try it. Yeah, enter the size. Yeah. Uh-huh.
1, 2.
See, it's printing out a memory location where the array is in memory. So that's not the way it works in Java, right? You got to print it out thing by thing.
So last thing, should I do dummy array?
That's what this method knows. All this method knows is dummy array. We're isolating logic. But when you pass in your real array, it's not going to be dummy array anymore that it treats, right? It will be, well, you can guess.
So would,
Yeah, that would go there. Exactly. Yes.
what's 3, 1, 2.
Yep. Okay, so again, you're doing dummy array. You want to do dummy array of I.
Right.
Okay, now instead of having 1, 2, 3 vertically like that, can you get the horizontal output?
Yes. And then should I do plus?
Plus equals space. Yeah, plus space, exactly. That way, when you, yeah. Mhm.
Okay. Okay, 1, 2, 3. Okay.
Perfect. So now we can revert back to the original task.
Okay. And we're going to be, we're still in this method, right?
This is just for display. You're pretty much done with this one, right? You made an array to this, you made a method to display these. Right. Your other task was to add all even elements of the array.
And return that integer value, right?
So go ahead and clean that array, that method up, because there are a lot of like unnecessary spaces. No, I mean, you don't have to erase it. You can just remove the empty spaces, right? Or you can do Control Shift L. Does that work? If you do Control Shift L, what does that do? Okay, forget about that then.
Okay. So we would do public static int, right?
Yeah.
And even elements.
Yeah, so just go back into the display array method just for a second.
Okay.
Like, add some unnecessary spaces anywhere you want. Like, after the bracket, yeah, there. And even more if you'd like. Let's say you were working on it. So if you do Control Shift F, try doing that. It will auto format it for you. So
Ooh,
okay. All right,
pretty
perfect.
cool. And I don't know, just array.
So camel case notation, right? Lowercase first.
Oh, I see what you mean. Okay, so we're going to be creating a for loop that iterates, that increments each element in the array is less than array dot length. And since it's less than and it's not inclusive, we can just do array dot length, right? Not -1.
Yeah, exactly. Exactly. Precisely. That's exactly what it is. Exactly what it is.
And then
Where are you going to store
Okay.
the
all right, we need a, let's say this equals 0, right?
So we can call it, we can be more descriptive. I was just doing that for the purpose of time, but always make sure to be descriptive. Sum is fine.
And I forgot, are we adding up all of the
Even element.
numbers? Okay, all of the even elements.
Okay, so before you do this, make another method that will just tell you if the number is even. And then you will use that method in this method.
Boolean?
Yes.
Okay. And then, I don't know. Or should I do elements or?
Element, whichever you like, or number. Yeah, element, sure. Number just seems a little more intuitive.
Yeah. Okay, so. If, should I do,
Mhm. So you want to save the value of your verdict or your, you can introduce a variable like Boolean result equals false. You can start by assuming it's false. That's what we generally do. We start by assuming something is not true. Okay.
if number minus 2
Equals 0.
equals,
Perfect.
would we return the results?
Exactly. So the idea here, if your number is even, then it will return true. And then it will not ever return it will, yeah, this is perfect. This is perfect. This is perfect. You get it.
So if is even, or should I just do if is even?
That works. That works. That works. Yeah, but remember, you have to pass a number to it, right? Remember
Right.
what it does, it accepts an int. Exactly. Exactly.
If is even array, then x, oh, sum equals, no, sum plus equals,
Perfect.
right?
Yeah.
Okay. I,
Yes, perfect.
okay. And then oh,
So you gotta actually, it's expecting a return type, isn't it? Exactly.
okay.
Yeah.
So, and what was the method name? Add even elements. My array.
Mhm.
Oh wait, we should probably print this out, right?
Print it out, store it in a variable, maybe store the result of the method in a variable. Either way, you could have just printed it out directly. It's just not good practice, right?
Yes.
Love evens, okay.
So, evens.
Yep.
Right. Let's try it. I understand what that. Oh, I
No,
guess we don't have to read.
yeah, you don't have to worry about those.
And let's do 5. 1, 2, 3, 4, 5.
That was the you displayed the array. And let's see.
Where did I get 6? I never typed in
Remember
6.
now it's what's that?
I
Okay.
wonder how I got 6.
Okay, so you go into display array.
Yeah.
Let's see here. 1, 2, 3, 4, 5. Here, send me this code here.
Okay. Hey, man, got the resistor.
How large would you be? Let's see. It's the problem is in your sum of evens. Okay. That is for sure. And let me go ahead and just show you how I know that. Okay. And again, this is more of a teaching moment than anything. Let me go ahead and share my screen. Okay, so look, I'm looking at the program, right?
Yes.
And I'm like, okay, dude, I'm doing two things here. I'm doing display array, because you see how I'm doing display array, and I'm doing this as well. So I'm like, okay, well, let me not do sum of evens. Let's see what happens then. Let me not, like, all I did was commented out sum of evens, and I ran the program. And I'm like, how large would you like your array to be? I say 5. 1, 2, 3, 4, 5. So now I know that actually my display works. Okay, that means that the answer, sum of evens, is 6. It is 6.
Oh.
So again, the lesson here is the importance of modularization. You get what I'm saying? Because look, I didn't have to go back and am I getting the input correctly? Am I, what if my is even logic was up here? Or what if my add even elements was up here? How would you figure out what the problem is? What I was able to do here, and what you'll be able to do every time you use modularization, is take out methods that you know work. Like display array works because it gives you the right answer. Then as soon as you add sum of evens into the equation, oh, you get the answer you don't want. That means sum of evens is the problem. But sum of evens is right, which means maybe the output is right. You know what I'm saying? So it's that mental debugging process that modularization allowed you to do. Okay. So there are some, if you go to Ahmad's notes, you're well equipped now to do every CSC 200, and there are not a lot of them, maybe only about 8. You do these 8 programs, and they're just like this, if not less complex. I assure you they're probably less complex. The later ones are probably more complex, but you do all of those and you would have done all that would be expected of a person in CSC 200 and pre-CSC 201, setting yourself up for object-oriented programming. So spend some time here in mechanics. These are what they call mechanics, of being able to mechanically make methods. Spend some time specifically here. Abhi 2 minute bas dance. Spend some time specifically here. I'll go ahead and open this up. Here. Have you heard of coding that?
Coding bad, no. Oh, wait, yes, I have.
So look, it says sum 2, given an array of ints, return the sum of the first 2 elements of the array. Or, just problems like this, right? Or, common end, given 2 array ints, return, there are problems like this. So if and there, this is array 1, maybe array 2 might be more up your alley. See here, it says count even. So, int sum equals 0, for int I is equal to 0, I is less than. It provides you nums.length I plus plus. If nums of I, modulus 2 equals 0, then I'm going to do sum plus equals nums of I, and then turn the sum, right?
Right.
I missed a few things here. It's actually for 5. I believe it's for 5. Or maybe it's not for 5. Note the mod, return the number of even ints in the given array. Remainder. So yeah, I mean, I did do that, right? Sum equals, why am I missing stuff here? Did I take into account 0? For int I is equal to 0, I is less than plus nums of I modulus 2 is equal to 0. Sum equals sum plus nums of I. So that should work ideally. Return the number of even ints in the given array. Mod operator computes the remainder, which I did. Something wrong here. Let's see. Modulus 2, I mean, they are even that way. Why is, so the red one symbolized the test cases that I'm getting wrong. So over here, it returned, it ran 8. 2, 4, and 8. So it ran 8, and these are all the even ints. 4 is even, 2 is even, and 2 is even. So technically this is right. 2 is even, so that 2 and 2, 4, it's asking for the number of even ints, not the sum. So it's not asking the sum of even ints, it's asking the count of even ints. So how many are there?
Oh,
right?
I got you.
So now I get them all right.
I got you.
Now, what you'll eventually learn is you can simplify your code. Good programmers will do something like this: count equals 0 for int nums in nums. If no, they'll probably do something like for each element in nums. If e modulus 2 equals 0, count plus plus, return nums, return count. They will really shorten their code in this way. And there are ways to make it even shorter, but so yeah, go and spend some time in these types of exercises. Has 12. If there's 1 in the array or somewhere 2 later on, or even odd, return an array that contains the exact same numbers as the given array but rearranged. And so all these are true for different types of problems. So really get comfortable with logic, okay?
Okay.
Great. All right, I got to dip out, but I'll send you this recording if you feel like you need it, and keep practicing.
Thank you, man.
Great, thanks, brother.
Thank you, bro.